Today, let me introduce the propositional logic in a discrete mathematic. First, we have to ask a question. What is a proposition, aka statement? It is a declarative sentence that can be either true or false. For instance, today is Monday. It is a proposition since it can be identified with true or false. There is also a non-example. Please close the door. It's an action, not a proposition, so we can to identify its value. So let's move to another thing. It's called truth table. Truth table can help us to find the results of logical operators and proposition. By truth table, we can evaluate complex reasoning by showing how operators affect proposition. So let's see example. On the horizontal axis is our propositions, and each row shows the truth value of logical operators on this proposition. So you will see 1, 2, 3, 4, 5 logical operators. And in today, we are going to show you 6 logical operators. So there is a key takeaway. Truth tables are essential for visualizing logical operator. It is a key takeaway. And we are going to show you the first logical operator, negation operator, aka not. So this operator is unary, so which means it only have one parameter. So let's see example. If P equals to I have brown hair, then not P equal to I don't have brown hair. So its meaning is easy to understand. It's just to transform a proposition into its negation. There is its truth table. So there's a second logical operator, the conjunction. It's also called AND. This operator is a binary operator, so you have to use two propositions. Let's see the example. If P equal to I will have salad for lunch, and Q equals to I will have steak for dinner, then P and Q equals to I will have a salad for lunch and will have steak for dinner. So there is its truth table. If P and Q are both true, their conjunction will also be true. Take a look at this truth table. You will find the fact that if P or Q, one of it is false, their conjunction will be false too. So if you want to P and Q's conjunction is true, both P and Q must be true. There is a third logical operators. The disjunction is also called OR. So this operator is also a binary operator. So you have to use two propositions to form their logical disjunction. Let's see the example. If P equals to my car has a bad engine and Q equals to my car has a bad carburetor, then P or Q equals to either my car has a bad engine or a bad carburetor. So there is its truth table. Take a look at it. You will find out that if P or Q, one of the position is true, the disjunction will be true. So as you see, the disjunction is only false when P and Q are both false. It's a total summary about two logical operators. We learned the conjunction and disjunction. You can start the video and to figure out what relations these two operators means. So there's another question we can think about. We know that a conjunction of n proposition will have 2 power of n row to write. Why? Since every proposition we have choose or not choose to choose. Choose or false. So if you want to the total result of this conjunction in a truth table, we have to write down 2 power of n row to figure out what the total result will be look like. There's a exercise about this. If there are 10 propositions types, how many rows we need? You can stop the video and write down it on the paper or whatever, and you will find the answer is 1024. It is 2 power of 10. So in there we have introduced 3 operators. They are the basis of every logical representation. But actually, in reality, we use unary and net to form the basis of every logical representation. Net is not plus n, nor is not plus or. So there's a exercise about logical expression with a operator we just learned. You can make it as a practice. I will show you the result in the next video. Right? So let's move to the false logical operator exclusive OR is a binary operator. It combines two propositions to form its result. Let's see an example to understand its meaning. If P equals to I will earn A and Q equals to I will drop the course, then P exclusive or Q equals to I will either earn A or drop the course, but not both. But not both is a key takeaway. Let's see its truth table. You will find out that if the two propositions are different, their result will be true. In other way, if their propositions are same, their result will be false. So back to the takeaway, but not both is short in there. Let's move to the fifth logical operator, implication. It seems like is and else, but not totally same. Let's see example to figure out the relation. P equals to you study hard, and Q equals to you will get a good grade. P implies Q means if you study hard, then you will get a good grade. But if you don't study hard, what's the result of Q? Let's see its truth table. If P is true, P implies Q will be sent to Q. So if P is true, Q is true, P implies Q will be true. If P is true, Q is false, P implies Q will be false. But if P is false, no matter what Q is, P implies Q will be always true. For instance, if I say pig can fly if penguin can fly, this description is true since the penguin will never fly. So you can't say pig can fly is true or false. There's another point about propositional logic, especially for implication, is DNF. So in a nutshell, it's a variation of implication. There are three types of variation. First is converse. It will change the place of proposition. P implies Q will be transformed into Q implies P. Second, inverse. It is to aid not in with a proposition. P implies Q will be negation P implies negation Q. Third, contrapositive. It is inverse of P implies Q, and to convert it, and its tautology, aka same meaning of P implies Q. Why? If you write down the truth table on the paper, you will find out that the truth table are same. Finally, let's move to the let logical operator by condition. It's also a binary operator. If P by condition is by condition to Q, it states that P is true if and only if Q is true. For instance, let's take a look about example. P equals to Bush wins the election, and Q equals to Bush will be president. P by condition Q means Bush will win the election if and only if he will be president. See a truth table. You will find that if P and Q, two propositions, are same, its result will be true. Don't you think it is similar to the operator we introduced? That's right. It's exclusive OR. This operator is like the not plus exclusive OR. So if two propositions are same, their result will be true. In the other hand, if their propositions are different, their result will be false. It's a summary and a review about the logical operators we learned today. First, negation operator, also called NOT, is an n-ary operator, and its symbol is look like this. Second, conjunction operator, also called AND, is a binary operator. It look like this. Third, disjunctive operator, also called OR, is also a binary operator. Its symbol is look like this. Fourth, exclusive OR operator, XOR. It's also a binary operator. It looks like a circle and a plus. Fifth, implication. Its nickname is implies. It's also a binary operator, and as you see, its symbol is a direction. The last one Biconditional operator its nickname is if IFFF is if and only if is also a binary operator and its symbol is the direction with two sides. So it's the end of this video. Wish to see you in the next video.